So without wasting much time, let's dive right into it. So the first one, which is the compound angle identities, is giving us for sine, because we have for sine, for cos, and for tangent. You understand? For sine, for cosine, and tangent. So for sine, the first one is giving us sine A plus B. If you have the summation of special angles, two special angles, sine A plus B, it is giving us sine A cos B plus sine B cos A, right? Sine A cos B plus sine B cos A. So let's assume you were asked to look for sine 75 degree. You can agree with me that sine 75 degree can be written as sine 45 degree plus what? Sine 30 degree, isn't it? So sine 45 plus 30 degree, the summation of 45 and 30 gives sine 75. So if I'm to do that, A is going to be 45 and B is going to be 30. So anywhere I find A, I will substitute 45 degree, and anywhere I find B in the compound angle identity, I will substitute what? 30 degree. So that's for what? The summation of what? Two special angles. The same thing here for sine A minus B. The difference between two special angles. You know, we have four special angles, right? 30, 45, 60, and 90 degree. These are the four special angles we have. And I will show you how to derive them from a triangle. So therefore, for sine A minus B, which is the difference between two special angles, say for instance we're asked to look for sine 30 degree. Sine 30 degree, you can agree with me that I can compute the difference between 90 and 60 to give me 30, right? Because 90 and 60 are two special angles, isn't it? So 90 minus 60 gives me 30. So sine 30 degree is giving us sine 90, which is my A, cos 30 minus sine 60 cos what? 90. I'll go over it again. Sine 30 degree, which is the computation, the difference between 90 and 60 is what? Sine 90 degree times cos 60 degree minus sine 60 degree times cos 90 degree. So that's how to get sine 30 if you were asked to look for it. Then how will you get sine 90? When I show you how to use the triangle, you can use that to get sine 90 and 60 and so on. You can use that to get all the special angles in their surd form. Now for cos, it is given as cos A cos B. Now if you want to make this thing easy for you, what I do is just keep on writing this till it can store in your muscle memory. You understand? Till you can store this in your muscle memory. Even though I wake you up by 1 a.m. in the morning, you can write these out without having to look somewhere else. You get? So just keep on writing this. You might make mistake. It doesn't matter. Keep on writing it. Look for, let's say, 10 plain sheets. Keep on writing all these compound formulas till you can store them in your memory. You can recall them. So that is that. So for the difference, it is cos A cos B plus sine A sine B. Now if you look at sine and cos, they have two striking difference. Now what are the difference? They have two differences. In sine, when I'm adding, the addition here remains, right? Isn't it? But in cos, when I'm adding, it's subtraction. You see, this is subtraction. When I'm adding, it's subtraction, isn't it? And the second difference is, this is sine cos, but this is cos cos. Cos cos, sine sine. So that's one of the difference again. So for cos A minus B, it is given as cos A cos B plus sine A sine B. So when it's minus, you have plus, and when it's plus, you have minus. So that's for cos. Then for tan, it's given as tan A plus tan B over 1 minus tan A tan B. Now, how can you be able to distinguish between the positive tan and the negative tan? For the positive tan, the denominator is having minus while still maintaining the positive sign here. This is minus. And the minus here is maintained, but the sign here changes in the denominator plus. You get? So this is for compound angle identities. You can use this to find angles that you can either sum up or subtract two special angles to get. You get? So if I can work with two special angles to give me an angle, then I'll have to apply the compound angle identity. You understand what I'm saying, isn't it? Now, these are angles that you can use compound angle identity to find without having to rack about looking for a calculator or a trig table. Now, the first one I have is sine 75. You understand? So if I can look for sine 75, definitely I can look for tan 75. Definitely I can look for cos 75, isn't it? Another one you can get is sine 90. Okay, that's much more easy because I have 60 and 30, right? Sine 90. Yes, you can still look for sine 90. You can look for sine 115. Yes, you can look for sine 115 because 75 degree, or rather not sine 115, I'm sorry. You can look for sine 105, sine 105, because it's the summation between 60 degree and 45 degree, isn't it? That will give you sine 105. So you can work with all this. Just pick your pen and write this compound angle identity formula till you can be able to register them in your muscle memory and you'll be good to go. So let's go to the double angle identity. That's the next one. I will do this letter, the half angle. Let's go to number 3. Number 3 there is double angle identity. Now, double angle identity is very, 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 very easy because it's just summing two angles, right? Summing two angles. And we have sine 2 theta, cos 2 theta, tan 2 theta. Those are the 3 double angle identities we have. Now, the first one is sine 2 theta. Now, see what I wrote here. By applying the compound angle identity for sine addition, sine 2 theta is given as sine theta plus theta. Because it's like saying 1 theta plus 1 theta giving me 2 theta, right? So sine 2 theta, which is a double, because of the 2, double, is given as sine theta cos theta plus sine theta cos theta. When you apply the compound angle identity rather for sine addition, when you apply the first one here, the first compound angle identity, when you apply it here, you will get the double angle identity for sine 2 theta, which is given as 2 sine theta cos theta. So this is it, 2 sine theta cos theta. How can you apply this in a question? Say for instance you are given sine 60 degree to look for. You can say sine what? 2 times 30 degree. 2 times 30 degree. So that's 2 sine, what's my theta? That's 30 degree times cos what? 30 degree. Then what you just simply do is to apply your half angle, sorry, not your half angle, your third form of 30 degree. You know, 30 degree is a special angle, so just apply your third form of sine 30 degree and cos 30 degree, and you are good to go for what? Sine 60 degree. So it's very, very easy to use your double angle identity when looking for respective values for sine, cos, and tan of various angles. You understand? So for cos 2 theta, which is double angle because of the 2 theta, by applying the compound angle identity for cosine addition, this is cosine addition, right? That's cos A cos B minus sine A sine B. Now, in this place, my A is theta and my B is theta. So that's given as what? Cos 2 theta equals to 1 theta plus 1 theta, which is cos theta minus sine theta, which is given as cos square theta minus sine square theta. So that's the first what? Identity for cos 2 theta. Now we have 3 identities for cos 2 theta. For the double angle identity for cos 2 theta, we have 3 identities. Now this is the second one. Recall that sine square theta plus cos square theta is equals to 1. I said that earlier on. Yes, is one of the Pythagorean identities that we are all familiar with. Now, can I then say that sine square theta is equals to 1 minus cos square theta? Substitute sine square theta equals to 1 minus cos square theta in cos square theta minus sine square theta. That is, I'm substituting sine square theta equal 1 minus cos square theta in this place. So anywhere I find sine square theta, what I will simply do is to impute what? 1 minus cos square theta. And that's what I did here. So this is cos square theta minus into 1 minus cos square theta. So if you extrapolate, if you FOIL, minus times 1, which is minus 1, and minus times minus cos square theta is plus cos square theta. So if you collect like terms, this is cos square theta plus cos square theta minus 1, which is 2 cos square theta minus 1. So this is the second identity for the compound angle, or rather for the double angle for cos 2 theta. So cos 2 theta is given as this. That's the second one. Remember, the first one is what? Cos square theta minus what? Sine square theta. This is the first one. This is the first one, right? This is the first one. So this is the second one. And we also have the third one. The third one is 1 minus 2 sine square theta. Just substitute cos square theta equal 1 minus sine square theta in what? The first one, in this place. Sine square theta minus cos square sine square theta. You will get the third one. That's 1 minus 2 sine square theta. So we have the last one for our double angle identity, which is tan 2 theta. Very easy. Tan theta plus theta, which is tan theta plus tan theta. When you imply the use of the compound angle identity for tan summation, which is tan theta plus theta plus tan theta over 1 minus tan theta times tan theta, which will give me 2 tan theta over 1 minus tan square theta. So that is that for the double angle identity. So we'll be moving straight into proving. We'll be verifying trig identities shortly.